everyone. This is Chris back again with the Ancient Scholar. So today I'm going to try to wrap up this concept of pH and hopefully bring in some final intuition to what's really going on with this pH scale. So as I talked about in the last lecture, I said, look, let's imagine, if you will, a liter of aqueous solution, we'll say water, and let's put a mole of protons, hydrogen ions, into that liter of aqueous solution. So here's my liter. Okay. Imagine that there's a liter of solution in here, and I put 1 mole of hydrogen ions into there, and of course those will then become hydronium ions as they interact with the water. And we talked about that a little earlier. And I said, imagine that in most biological situations, when we talk about acid-base, with the body and organisms and things like that, this 1 mole per liter concentration of acid would be an exception. It would be a statistical outlier that we would actually see any kind of concentration this incredibly high in any biological system. Certainly we would not see this in any living human being. So for all practical intents and purposes, we can say that 1 mole per liter, that's about as acidic as it really gets under practical situations and circumstances. So 1 mole per liter we'll just say is our base. And I said, well, what if I take a logarithm with a base of 10, and I turn this 1 mole per liter into a log, or I take the log base 10 of 1 mole per liter. Again, a logarithm is just one of those it's a method of making sense of incredibly large numbers, or in the case of this, incredibly small numbers. And I said, okay, so what is the log base 10 of 1 mole per liter? Well, the log base 10 of 1 mole per liter is 0. Because basically what I'm doing is I'm saying, what is the log base 10 of 1? It's 0. And then I said, well, let's push it a step further, and let's take this molar concentration and let's dilute it 10 times. Let's make it 10 times weaker, and we'll make it 0.1 moles per liter. And what's the log of 0.1? Well, the log base 10 of 0.1 is -1. Now let's make it yet 10 times weaker still, 0.01 moles per liter. And what is the log of 0.01? -2. And let's go ahead and make it even 10 times weaker. So you can see what I'm doing is it's 10 times, 10 times, 10 times, 10, 10, 10. That is the base 10 of my logarithm. So 0.001. Again, as my decimal point moves to the left, it gets smaller. As it moves to the right, it gets larger. In this case, we're going smaller. Moles per liter. And that's going to give me -3. And so on and so forth. And that is how we convert these very small numbers, 0.001 moles per liter. Now that's a small number, but remember, a mole is a massive number in itself. It's 6.022 times 10 to the 23 hydrogen ions. That is a massive number. So we're actually taking just a fraction of that massive number. So 0.0001 moles per liter is still a whole lot of hydrogen ions, okay? It's just a fraction of a mole. But what we're doing is we're using this log to turn it into these numbers that are a little easier to deal with. Okay, so if you guys are following me so far, I want to go ahead and just add in the final bit of intuition here. And that is, do we like negative numbers in our day-to-day life? And I think most people would agree with me, or maybe not, but I look at it like, not really. I don't like negative numbers. They're not all that intuitive. They're ugly. I like the symmetry that comes from positive numbers. I just don't like that negative there. So what we can do is we can take the negative log here. And basically what I can do is I can take the negative number and I can take the negative log of that. And of course, what's a negative times a negative? Well, it yields a positive number, and that 3 will become a positive 3. And it kind of got cut off there on the video there, positive 3. Now, I think a lot of people will go, okay, negative log of a negative number, oh boy, that's not all that intuitive. The way I look at it is, all these negative numbers, I just take the absolute value. So what's the absolute value of 0? That's what those little brackets mean there. The absolute value, well, it's 0, right? Absolute value is just how far something is from 0. Let's take the absolute value of negative 1. How far is negative 1 from 0? Well, it's just 1 from 0. That's the absolute value. Negative 2. What's the absolute value of negative 2? It's just a 2. So I just look at it as taking an absolute value, even though it is technically the negative log of these numbers here. I just look at it, well, what is the absolute value? So when we do that, 0 remains 0. And if you guys remember the pH scale, it went like this. And it started at 0, and 0 was really acidic. And hopefully now this makes sense. The reason it's so acidic is because 0 is the log of 1 mole per liter, which, as we explained earlier, is really incredibly acidic. Really acidic. That's almost like pure hydrochloric acid, HCl. It's really some acidic stuff there. And that's why 0 is so acidic, because the log of 1 is 0, and the negative log of 1, of course, is 0, 0, 0. So that's what 0 actually means in our pH scale, is that it's actually 1 mole per liter. And then we go all the way up here to 14, and 14 means that it's 0.00000, and so on and so forth, 1. An incredibly small number, and that it becomes a negative 14, but remember, we take the absolute value of that to be 14, and 14. So that's why 14 is up here in the really basic region, and not down here. So 0 is telling me 1 mole per liter, and then I move up to pH of 1. Well, that's just this guy here, 0.1 moles, so 10 times less concentrated. And then my pH of 2 is 0.01 moles per liter, a little 10 times less. And then pH of 3 is 0.001 moles per liter, 4, 5, 6, 7, 8, 9, all the way up to 14. So as you can see, on the pH scale, just going up one number, one whole number, from 1 to 2, if I go from 1 to 2, I'm going more basic, and that's telling me it is 10 times, or an order of magnitude more basic. Or if I go from 7 to 6, what that's telling me is that it is an order of magnitude more acidic, or 10 times more acidic. So hopefully that really brings home the intuition of what's really going on with the pH scale is really what we're doing with the pH scales. We have to use a negative logarithm to make these incredibly small numbers mean something. Because when you look at a number with 14 zeros, does that mean much? Not really. You can't really wrap your head around it, but you can wrap your head around a whole number. And obviously charting would be just a nightmare if I had to put all these zeros in. And obviously the error, the chance of making an error could be quite a bit higher. So hopefully that is actually, or everybody has at least an intuition now for what pH is and for what the pH scale is. And if people really want me to, I can kind of do a video on, you know, what substances fall into what pH ranges and things like that. But really, the goal of these 4 videos was really to provide some intuition as to what was really going on with this scale. Okay, guys, have a great day. Take care.